Hello everybody. The purpose of this video is to walk you through the steps for solving a three variable system of equations. And in this case we'll have three different equations, and so we can label them A, B, and C. And so we look at this, our goal should be how can I go ahead and eliminate one variable at a time, so that I end up with two variables and two equations. Because when you have two equations with two variables, you already have both the skills and the knowledge on how to go ahead and solve a two equation system. So that becomes the hard part here, is just staying organized and getting to that point where you end up with two variables and two equations. So if we look here and we look at our variables, we'll see that three x, y, and z are our variables, and if we look at the three equations, it looks pretty evident to me that x is the easiest one to eliminate, although certainly you could make another decision and do just fine. But I'm going to go ahead and eliminate x. And the reason I'm going to do that to begin with is because b and c are already set up to eliminate x. So I just copy those down. And go ahead and use our elimination process here. So by adding these together, because they're opposites, we've intentionally set that up so that the x's eliminate, and now I have 6y minus 10z is equal to 4. And that becomes a new equation, two variables, new equation, and we'll call that D. Alright, so now I can use A and either B or C, so might as well, A is already in a position to be eliminated, don't need to adjust that, so I just write that down. 2x minus y plus 2z is equal to negative 7. Now with the x's, if I multiply through b by negative 2, or I'm sorry, just plain 2 times b, then I'll end up with the opposite of the x in the x category, x variable. So I end up with a negative 2x plus 4y minus 8z is equal to 10. And go through the elimination process again, and just my x's will cancel out again intentionally, and this becomes 3y minus 6z is equal to 3. And now I have my new second equation, E. Alright, so now if I look at D and E, look at D and look at E, okay, now I got to sit there and say, alright, well, what could I eliminate from those two equations? And it looks like the y would be the easiest one to eliminate, and I can do that by just copying down D in its original state. 6y minus 10z is equal to 4, and then multiplying by negative 2 my E, and that would give me a negative 6y plus 12z is equal to negative 2 times 3 is negative 6. Now I go through that process. Again, y's cancel out intentionally. This gives me 2z is equal to a negative 2, z is equal to a negative 1. So now that I know what z is equal to, I can solve it in either D or E to find out what y is. Let's just go with E. So I've got my E, and I replace my z with negative 1. Minus 6 times a negative 1 is equal to 3. So this becomes 3y plus 6 is equal to 3. 3y is equal to 3 minus 6 is a negative 3. Y is equal to negative 1. Okay? Again, now I look here and I've got my z. I have my z, sure. And my z is equal to -1, and my y is equal to -1. So now I look back at my original equation, any one of them, and I go ahead and plop in the values that I know, which are y and z, and any of them. So I can say 2x minus a -1 plus 2 times a -1 is equal to a -7. So I end up with 2x plus 1 minus 2 is equal to a -7. 2x minus 1 is equal to a -7. 2x is equal to a -6. X is equal to a -3. And that becomes my third of the three variables. And so now I have my ordered triple of -3, -1, -1. And just plug it into the other two and see if it works. So I end up with a -x, so that becomes a +3. So this is in B. End up with a +3 minus 2, +4 is equal to 5, which is true. And for C, I end up with a -3 minus 4 plus 6 equals a -1, which is true. So my ordered triple ends up being this value here. X is -3, Y is -1, and Z is -1. I hope you found this helpful, and you can use it in your further studies.